Question 33 presents us with this system of equations and asks us to find the value of x. Anytime you're dealing with a system of equations, there are at least two ways to solve. Substitution and elimination are the two most common methods, although there are additional methods that involve matrices. Depending on your preference, you might naturally go for either substitution or elimination. However, there are cases where the question is set up in such a way that substitution might be faster than elimination, or vice versa. In this case, elimination is actually a little faster than substitution, although they will both always work. To use elimination here, since our goal is to solve for x, we would like to get rid of the y's if possible. One way we can do that is by multiplying the top equation all the way through by -1. Doing so gives us -4x minus y equals -4. We can see that by multiplying the top equation by -1, we've put ourselves in a position where, upon combining the two equations, the y's will cancel. We have a plus y in the first equation now, and a negative y in the other equation. Combining these two equations then, we get 4x equals 1. And solving for x, we find x equals 1/4, which you can also bubble into the free response as 0.25. For those of you who prefer to use substitution in cases like these, we can see that we'll get the same answer. The process of substitution involves getting one variable in terms of the others. Again, using the first equation, for instance, we might say that y is equal to -4x plus 4, which we can obtain by subtracting 4x from both sides. Now that we know y is equal to -4x plus 4, we can take that and put it in for the y in the second equation. As you might imagine, this is where the name substitution comes from. The second equation can therefore be written as 8x plus -4x plus 4 equals 5. Combining like terms, we get 4x plus 4 equals 5. Subtracting 4 from both sides, we get 4x equals 1. And this yields the answer of x equals 1/4.